Alright, Chem students, today we are talking about enthalpy. Please have out your blue note packets. We're going to work on page 3 today. Okay, enthalpy, or H, of a substance represents the heat content of the material. The change in enthalpy is the difference in the heat content between the products and the reactants. Okay, it is always products minus reactants for every single chemical reaction you will ever do. Products minus reactants. Okay, now we have also called change in heat, or the delta H, heat of reaction. So keep that in mind as well. Now, if we have the direction of the heat flow going out of our system, the sign on H will be negative. If it is negative, like we learned from our diagrams, that means it is an exothermic reaction. Heat is leaving. If heat is flowing into the system, the sign on the change in H will be positive. Positive means endothermic. Okay, a thermochemical equation is a chemical equation that gives information about the heat change during the reaction. The change in H is also known, like I said, as the heat of the reaction. Now, we have an example here of a thermochemical equation where heat is on the product side. We have two hydrogens plus an oxygen reacting to form two liquid waters, and 572 kilojoules of energy is released. So the change in H for our reaction is minus 572. Now we have two ways of deciding by looking at this what is our reaction, exothermic or endothermic. If the sign on the change in H is negative, that tells us it is exothermic. Also, if the heat is listed on the product side, right here, that also means that it's an exothermic reaction. Our next one is an endothermic reaction. The thermochemical equation has two waters plus 572 kilojoules as reactants, and that produces two hydrogens and an oxygen. Now, because the energy is on the reactant side, that means the energy is going in as a reactant. Also, our number on the change in H is positive. So both of these things signal to us that we have an endothermic reaction. Okay, so our heat of reaction can be calculated by the following formula. Like I said, always products minus reactants. Now we can look up the heat of formation for all of these things. There's a table in the back of your notes at the end. And like I said, always, always, always products minus reactants. And if you have a coefficient in the balanced equation, you are going to multiply that value times that number. So if I have two H2Os, I need to multiply 2 times whatever value we get for water. And the last thing that's super important is the heat of formation for an element. Just an element by itself in its standard state is always 0. Okay, our first practice equation. Find the heat of reaction, the change in H, and state whether the reaction is exothermic or endothermic. Then write in the change in H value on the correct side of the equation. So we have solid calcium oxide plus H2O, and that's reacting to form calcium hydroxide. So the first thing we're going to do is look up what calcium oxide is at the back of our notes. It is minus 635.5, and we're going to look up water, which is minus 285.8. So let's add those up and see. We get minus 921.3 for our reactant side. Now for our product side, we get minus 986.6. So let's figure out what we need to do. So the change in heat of the reaction is products minus reactants. We have minus 986.6 minus a negative, make sure you keep the sign even if you have two of them, a minus a negative 921.3 which means that will come out to be minus 65.3 kilojoules. Now automatically we can see, because there is a minus sign here, that means heat was released. So we know it's exothermic, and we also know that when we put the heat up in the equation up here, it needs to go on the product side. Okay, for our last example, it's your turn. See if you can use the chart at the back of your notes and figure out whether or not this is exothermic or endothermic, and then write in the change in H value on the correct side of the equation. Okay, let's see how you did. So for our reactants, we have nitrogen and oxygen. Both of those are elements in their standard state, so both of those are 0. When we look up our product, we get 33.9, and because there's 2 nitrogen dioxides, we need to have 2 times 33.9. So when we go over here, our change in H for the reaction is products minus reactants. We have for our products 2 times 33.9 minus 0, which means our final answer is a positive 67.8 kilojoules. So automatically we know it's positive. We know this is endothermic, and because it's endothermic, it's going on the reactant side. Okay, that's it for today's lesson. Make sure you do the pages in your white packet.